Hello everyone. I hope you're all doing well. We're looking in this video at question 14 on part 1 of our Alberta math contest. What do we got? Let A be a real number so that, this is a quartic equation. X to the 4 minus 2ax squared minus x minus a plus a squared equals 0 has 4 different real solutions. So we want this quartic to have 4 different solutions. Which of the following must be true? It looks like we've got some ranges of values for A, and the classic, maybe none of these is the right one. Okay? Usually expect that on the Alberta papers. Okay. What can we do here? So I notice it's quartic in X. Let's just copy down the expression. X to the 4 minus, I think it was 2ax squared, or was it x cubed? 2ax squared minus x. If it wasn't for that minus x, we could have introduced it. So sometimes, if I didn't have the minus x, something you can do is you can say something like, let y equal x squared, and then really you've got a quadratic. They're just being sneaky about it. Because of that minus x, this is a real quartic that we're really going to have to deal with. It is minus a plus a squared. Okay, that's what I thought. So this is quartic in X, so the largest degree is 4. But you can notice it's quadratic in A. Okay? And we are more concerned about A necessarily than X. So that's something. So we might want to rearrange and rewrite this so it's a polynomial in A. Maybe they're just trying to be sneaky about this. So we get a squared minus 2x squared plus 1 times a plus x to the 4 minus x equals 0. Okay, so that's it as a quadratic in A. And so we might get a better handle on A from here, because now we could do something like the quadratic formula. I mean, you could try and factor this, but I'm not the best at factoring polynomials like this, so I think it's best just to use the quadratic formula. So we'll get negative b plus or minus square root of b squared. So we'll do this on the next page. Minus 4a, and then our c here is x to the 4 minus x. Now hopefully the x to the 4 coming here might cancel something out. And then this is all over 2. Okay. So, 2x squared plus 1 plus or minus. Now, expanding out the 2x squared plus 1 squared, you get 4x squared plus 4x to the 4 plus 4x squared plus 1. And then it's going to be minus 4x to the 4 minus minus, which is a plus 4x. And then those cancel out. 2x squared plus 1 plus or minus square root of 4x squared plus 4x plus 1. But of course this we might better recognize, especially if we're good at our perfect squares, as 2x plus 1 squared. So those, the square root and the square will cancel out. We're left with 2x squared plus 1 plus or minus 2x plus 1. So we either get 2x squared plus 2x plus 2 all over 2, or 2x squared minus 2x, and then the 1's will cancel out over 2. So a is either x squared plus x plus 1, or a is x squared minus x. Okay. So now I've got a as it relates to x. How does this help us? Well, what do we know? We know that our original quartic has to have 4 distinct solutions. So now if I take each of these, I'll still have a kicking around. There's my constant a. But now I've got quadratics in terms of x, and these I should be able to solve. And so a can be lots of different values, but the a must relate to the different possible x's in these ways. Okay? So for a given a, these equations must be solvable. And so these will produce, I hope, 4 different values of x, and that's something we might have to check in a little bit. But here, solving this equation, x is going to be negative b plus or minus square root of b squared minus 4ac, which in this case is just, the c is 1 minus a. And over here we get 1 plus or minus square root of negative 1 squared minus 4ac. All over 2. So you'll get, you can at least say, I'll get 2 distinct real roots for both of these equations if the discriminant, if the thing under the square root sign is positive. Will that also necessarily mean that the x's I get over here and the x's I get over here don't overlap? That's something we might need to check out. But to get 2 real roots, we'll need what? 1 minus 4 plus 4a. That needs to be positive. And 1 minus a 1 plus 4a needs to be positive. So 4a needs to be greater than 3, bringing the 1 and the 4 over. And 4a needs to be greater than negative 1. Well, this one is satisfied when this one is satisfied. So really we just need a to be greater than 3/4. And that seems to be it. A has to satisfy that. And if you remember our answers, they all are a bunch of inequalities. And you'll see 3/4 appears a few times. Right? So, now C has the property that A is greater than 3/4, but they're also telling me that it has to be less than 1. I don't know how the 1 necessarily fits in. So I think it could be C or D. Of course, it could be E, and strictly they're saying, you know, you just need this. It's nothing so specific as these. But let's take a closer look, because maybe you have to be less than 1 in order for the roots here to not overlap in any way. Are any of these roots going to be the same? So that's our new question. Can we find, is there one of the plus minuses over here in terms of A that's equal to one of the plus minuses over here in terms of A? So we get what? 4a minus 3 over here. And you would need to be equal to at least one of these ones over here, which is what, 4a plus 1, I think? 4a plus 1. All right, so we don't need to bother with the divide by 2. Just multiply both sides by 2. Okay, now, minus 1 minus something, that's definitely got to be negative. The only negative 1 over here would be 1 minus root 4a plus 1. So let's rearrange these. Let's bring the 1 over to this side. Multiply everything by negative 1. And now ask, is there a value of a in this range that makes these two equal? I don't think so. But let's see what we can see, I guess. Squaring both sides, I guess you get 4 is equal 4 plus 4 root 4a minus 3 plus 4a minus 3 is equal to 4a plus 1. 4 A's cancel out. Those cancel out, and so you would need to have 4A minus 3 equal to 0. So A would need to equal 3/4, and we're specifically talking about A's that are greater than 3/4. So there's no way -1 minus something over here can equal one of these. So definitely distinct roots there. Now the question is, what about -1 plus something? Could that be equal to one of the ones over here? And there might be a bit more of a possibility. Okay. Now 4A plus 1 is definitely bigger than 4A minus 3. So their square roots are bigger. And so 1 plus a bigger thing is always going to be bigger than -1 plus a smaller thing. So we won't have the plus here. The only option is -1 plus this amount is equal to 1 minus this amount. Okay. So we play basically the same game we did last time. Multiply by -1. The only change is going to be a minus sign here. And all that'll do is change a minus sign here, and so a minus sign here, and you'll still have A has to be equal to 3/4 for there to be a root of this polynomial that's the same as this polynomial. And so that can't happen. It can only happen at 3/4, and we're specifically saying A is greater than 3/4. So any A greater than 3/4 will do. So none of this one stuff, they tried to scare us, it didn't work. And so I believe the answer is going to be E. None of these is exactly correct. You do have to watch out for that sort of a thing. All right, so that's it for question number 14. We've got 2 more to go. So in the next video, we're going to be looking at question number 15. So join me if you'd like. If you haven't taken a look at 15 or 16, feel free to give them a try. And I'll see you for more of our Alberta math contest in the following video. Take care.